Hello, friends. You have tuned in to episode 54 of the Our Weekly Highlights podcast, where I take a deeper dive into the highlight posts originating from this week's issue of Our Weekly. My name is Eric, and today we are covering the issue highlights for week 34, released on August 23rd, 2021. This week's issue is curated by Miles McBain, with help from the Our Weekly team members and, as always, our community of contributors. Throughout the month of August, we have learned about valuable packages and principles to navigate yourself out of a jam, including the flow package we learned about in the last episode and Mael Salmon's guide on becoming a better code detective. Certainly, the main focus tends to be on the actual R code we write, but that is only a small part of the overall session. The majority of R programs utilize one of the biggest selling points of the language, and that is the community of packages extending the capabilities for analysis. While in a perfect world, every package would contain uniquely named functions, that is simply not the case. A simple yet very powerful technique that typically helps prevent conflicts is to prefix the function name with the package name. But there is a fairly intricate interplay with object environments every time a function is executed in R, and data scientist TJ Marr found himself inside what may have felt like a twilight zone trying to navigate a bewildering problem in our first highlight today. TJ, like many of us, was leveraging the tidyverse for data manipulation to complement statistical modeling. The select function from dplyr, arguably one of the most common functions to run during a tidy data workflow, unfortunately conflicts with the mass package's version of select. Mass happens to be the companion package to the Modern Applied Statistics with S manuscript and book, authored by our core team members Bill Venables and Brian Ripley. In a normal situation, where you are executing code in a main R environment, using the namespace prefix technique ensures R is only searching in the namespace of the package of the supplied prefix when executing that particular function, which TJ clearly defined in the example code of his blog post. But here's where the mystery begins. Similar to what I do routinely in my complex analyses, TJ wrote code in separate R scripts and would execute those in the R session via the source function instead of typing everything as one massive R script. But whenever the code from another R script that happened to call select from dplyr was executed in the main session, the select function was still coming from the mass package. Just what is causing this strange occurrence, you ask? Well, the source function has more going on than it appears. By default, running source to run code in a file will do so inside the global environment, which is where most of the data and objects you create live during your R session. However, by setting local to true inside the call to source, that ensures the code inside the script is executed in the same environment as where it is called. Sure, if you're sourcing a few files at the beginning of an analysis script, that will also mean you are running code inside the global environment. But in TJ's case, he was sourcing scripts inside separate functions as part of a sophisticated knitr and R Markdown workflow. So, by simply flipping that bit of local to true, everything works just as intended. Now that was certainly a lesson learned for sure, and I doubt if TJ is going to be encountering that same mistake or that same situation anytime soon. But that goes to show you that it is not just writing the R code. You have to think about where and in what particular portion of the environment this code is executed in. In fact, when I was beginning to learn Shiny and before modules became a thing, I noticed that a lot of people were writing their Shiny apps that reference other scripts but used local equal true. That seemed kind of magical to me, but now it makes perfect sense. They wanted to ensure that that script was being used inside a custom environment of, for example, a reactive object or an observed event or things of that nature. So, as always, I'm learning something new with this, and obviously TJ learned a lot through this exercise as well. We'll also have a link in the show notes to a very promising new package that TJ is making that's based, in essence, a R Markdown notebook project that is fundamentally using the Targets package by Will Landau. One of the pillars of statistics and data science is, of course, modeling, which we'll be hearing about in both this and our next highlight. And in terms of judging model performance, there are a boatload of metrics depending on the model you're performing. For example, in the typical regression model, we often have metrics such as the Archaic Information Criteria, or AIC, or even the Bayesian Information Criterion, or BIC, which both assess a statistical model's goodness of fit when factoring in the predictive variables. But in statistics, at least from my perspective, quite a few of these metrics and diagnostic measures can seem quite abstract. Much like how we learned about visual techniques helping with, say, debugging, there are ample opportunities to illustrate fundamentals of model fitting and diagnostics via visualization. Andrew Heiss, assistant professor in the Andrew Young School of Policy Studies at Georgia State University, saw some common themes during his past lectures on regression modeling and decided to take a new approach in shedding a new light on key model diagnostics in our second highlight today. A key principle of statistics is knowing that there is no such thing as a perfect model, and in the real world, we experience variation in many forms that we at least try our best to account for by including relevant predictors inside our models. Andrew found that many of his students related to a particular metric called the coefficient of determination, also known as R squared, which in a nutshell gives the percent of variation in the response variable of a model when applying the predictor or explanatory variables. It's one thing to see that R squared value in the printout of summary statistics from, say, an R or Python model fit and measures of from a regression model, but Andrew was inspired to illustrate more context behind the visual by constructing Euler diagrams with the aptly named Euler package by Johan Larsson, alongside some custom functions to compute the sums of squares, which are fundamental to this illustration. Andrew's blog post takes a journey to build up the visual story. As one nice benefit of Euler diagrams, as opposed to a typical Venn diagram, is that the circles are sized based on a metric such as, in this case, the sums of squares. Then he applies the AOV function in R to obtain the covariation amongst the outcome and predictor variables, which in turn updates the Euler diagram to show an overlap between the two model terms, which one can think of as that explained variability that R squared is trying to tell us. As the model scales up to include more than one predictor parameter, more care is needed to obtain the proper variability calculations in light of the different combinations possible. But in the rest of the post, Andrew illustrates that with more than one term, that we can see that the R squared shown visually in the Euler diagram is becoming smaller as more terms are added, which is another key principle in this concept. Now, there are a few caveats to this workflow, some of which include the manual calculations of the different covariation segments and how there are some cases where some datasets could result in negative areas of the chart, which of course won't exactly render nicely in this workflow. But it goes to show you that with a little visual prowess, one can easily make a concept like the coefficient of determination, or perhaps even other measures, a lot more relatable, especially to those that are new to statistics and data science. And now for our last highlight for today. You have heard me say more than a few times on this podcast and in my other content creations that one of the main reasons I am so happy to be part of the R and in general data science communities is just that, the community. There has certainly been a lot of efforts to give ourselves that community-like interaction, especially in light of our current situation with the global pandemic. Some work really well, and some have been out of necessity, such as making conferences more virtual. But sometimes it's hard to replicate that great sense of community that you might get at one of these events, say via the hallway conversations, or everybody just getting together and geeking out on cool techniques in data science and the like. Well, I'm happy to report that even there's been a great new effort to make the concepts of data science and machine learning entertaining and engaging to the general community. And what am I speaking of here? Well, I am speaking of a unique blend of an esports-like competition and reality game show, all with interactive community elements, and this effort is called Sliced. Sliced was originally created by Nick Wan, data science manager at KFC, and he also got the idea from his co-host, Meg Risdell, a product manager at Kaggle, in which they had a simple conversation on Nick's Discord channel, thinking about some cool creative ways to try something new with respect to data science and statistical modeling. And the unique features of Sliced is that in each episode, there are 4 contestants who get to analyze a data set they have never seen before, and they are asked to complete their exploratory data analyses, visualizations, and model fits in a 2-hour window, all live for the entire world to see. Does that sound intimidating? Yeah, it kind of does, but it's also highly entertaining and frankly illuminating when you see the workflows of such talented data scientists across so many different industries try their techniques on these data sets and all the adventures that can happen along the way. Even our weekly curator Tony Elharbar was part of this season as well as the pilot season a year ago. In fact, he wowed the audience in his sessions with not just his great data science skills, but also his eye-catching themes when using RStudio, and of course, his top-notch meme game. Nick and Meg are quick to acknowledge that Slice won't be the best way to teach all of the nuts and bolts of, say, machine learning model interpretability, but it offers a very unique take on the end-to-end process of data exploration and data modeling, and being able to see in real time the techniques and tooling each contestant utilizes in their workflows. And community was front and center with this, where unlike if you're watching a simple reality show on your TV, you are able to watch these episodes live on Twitch as they happen and interact with the rest of the audience in the chat for some very fun banter. And it doesn't just stop there. Each data set is available in the open once it is launched in each episode via Kaggle, which means that if you want to try your hand at doing some model predictions and having fun with the data set, you have all the means to do so. And those are tracked alongside the actual contestant results on the leaderboard that's shown throughout each episode. There are a lot of moments throughout the season that covered a full spectrum of exhilarating insights, hilarious memes in the heat of competition, and even the eventual champion, David Robinson's absolute dedication to try and win more chat points as part of his score, and even pulling out a huge surprise at the end of the finals. There won't be any spoilers here. You have to see it for yourself. And community was such a strong theme throughout the season, so much so that even one of the contestants, Landon, was able to land a job in data science midway through the season. Talk about an audition, right? If you can be good at Slice, I imagine you'll be pretty good at data science in general as well. Most of the Season 1 episodes are available on demand on YouTube and Nick Wan's Twitch channel, and it is sounding like we will indeed have a Season 2 next year. We will have links in the show notes to where you can find much more information on Sliced, as well as the recent podcast interview that Nick and Meg took part in on the Practical AI podcast, episode 144. And something tells me you may be hearing from Nick and Meg on another podcast in the near future. And I also invite you to check out Nick's other data science streams on his Twitch channel if you'd like to see a really solid professional's take on analyzing some pretty complex data sets and having fun along the way. And those are your R Weekly highlights for today. It's par for the course, as they say, as Miles has put together an excellent issue for us to look at this week with great new resources, including a big update to the version 1.0 of the Infer package, an analysis of recent political trends in Afghanistan, a great roundup of recent Shiny applications from the Shiny contest applied to healthcare, and much more. As always, I am so thankful for all of you around the world tuning into this podcast, as well as visiting R Weekly each week. We are certainly excited to bring you all this excellent content that is once again made by the community and for the community of R and data science. And I always welcome your feedback on this podcast as well as my other adventures, so feel free to give me a shout on my Twitter account with the handle @thercast. And you can also look at the podcast page at rweekly.org for the little contact link if you'd like to get in touch with me on there. Have a fantastic week, and we'll be back with another batch of our weekly highlights next week.